Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading and helping you out. Please guys do share this video guys to your peers. Ne? I know that a lot of learners usually struggle with dealing with a question with two balls that's thrown one after the other, and they have to meet somewhere somehow. So this video guys is the most important video from all the 12 videos. Okay, let's just get right into it. Ne? A small disk C is thrown vertically upwards at a speed of 15 meters per second from the edge of a rooftop. Okay, rather from the edge of the roof of a building of height 30 meters. After 0.5 seconds, a small ball B is shot vertically upwards from the foot of the building at a speed of 40 meters per second in order to hit disk C. Okay, explain the term projectile. Okay, but before we start, the motion of ball C will start here, go up, reach maximum height, and then come to the ground. And then up B will just go. Let me indicate ball B with the blue color. Go upwards until it hits ball C. Maybe let's call this place over here point X. So the initial point here will work for motion ga C. The initial point is P, maximum height is Q, and then the ground, let's call the ground point R. Point R for OC, ne? Yeah, Mara, the ground is just R for both. The ground is position R. Okay, it's important, guys, for us to label the motion because it's easier for us to calculate. And we must declare which direction we're taking as positive. Let's take up as positive. Okay, explain the term projectile. A projectile is when an object is given an initial velocity and it travels under free fall. Remember that free fall, guys, is the motion under the influence of gravitational force only. So a projectile is when a ball is given an initial velocity and it travels under the influence of gravitational force only. Okay, calculate the time taken by disk C to reach its maximum height. We are just going to focus on path PQ. The initial velocity, since we've taken up as positive, that's positive 15 meters per second. Final velocity, that's 0 meters per second. At point Q is the maximum height, so the velocity is 0 meters per second. I don't know the distance it traveled to reach maximum height. I know gravity is 9.8 meters per second squared, but since I've declared that upwards is positive, my gravity has to be negative. Are we together? And then what else? Oh, the time it takes to reach maximum height. That's what I'm looking for. For me to answer this question, guys, I must refrain from using any equation that has delta y. Why? Because I do not know the distance traveled by the ball to reach maximum height. So I'm simply going to use the first equation, which simply says Vf is equals to Vi plus G delta T. So the final velocity will be 0. Initial velocity will be 15 plus negative 9.8 delta T. If you take the 15 to the other side, it will be negative 15 being equals to negative 9.8 delta T. Divide both sides by negative 9.8. You'll simply find that the time it took for the disk to reach maximum height, that's 1.53 seconds. So the time it took for the disk to reach maximum height is 1.53 seconds. Okay, then second question, they want us to find the maximum height above the ground reached by disk C. Okay, we already know that from the top, from the ground to the top of the building, that's 30 meters. So for us to find the maximum height above the ground, we just need to find the distance traveled by the ball from P to Q and then add it to 30. All together. For us to find the distance, we are still going to consider information PQ, but please guys, refrain from using the values that you calculated on your own, because maybe you could have made a mistake. So just use the information that is given, unless you are pushed to use what you have calculated on your own. Are you together? So I'm still looking at this data over here. I want to find delta y. I will approach this question as if I don't know the time it takes to reach maximum height. It simply means I will refrain from using any equation that has time. So I'll just go to the second equation. Vf squared is equals to Vi squared plus 2g delta y. Final velocity is 0. Initial velocity is 15. I have negative 9.8 and delta y. So 15 squared, that's 225. Let me confirm. Yeah. When I take it to the other side, I'll have a negative 225 being equal to negative 19.6 delta y. Divide both sides by 19.6. You'll find that delta y is just 11.48 meters. 11.4. Let me confirm. It's 11.48 meters. Ne? So the height, the maximum height above the ground, is just 30 of the building plus 11.48, which will give us 41.48 meters above the ground. Okay, now I must calculate the time from the moment that ball C is thrown upwards until the time ball B hits disk C. Let me erase here. So we are focusing on the ball and the disc, ne? Okay. There are things I want us to notice over here, guys. This is the height. Oh my god. This is the highest point of the building, ne? Which simply means that this distance over here is 30 meters. The distance over there is 30 meters, right? So when the ball hits the disc, the ball would have traveled the length of x meters above the ground. Are you together? So it simply means that the distance over here is just 30 minus x. Are you together? So basically all I'm saying is that for me, whenever I focus on the ball, ne? Whenever I focus on the ball, the displacement traveled by the ball before it hits the disc, that's x. Are we together? And whenever I focus on the disc, the displacement traveled, that's 30 minus x. Are you together? But remember that the disk, guys, was there at the top, but now it has traveled downwards for 30 minus x units. Every downwards movement is negative. Are you together? Obviously, if you multiply the bracket by negative, you'll simply find x minus 30. So this will be my displacement, guys. Okay, and then now let's deal with time. Okay, since the disk was thrown first, we can simply say the time is equals to t. Are you together? So if the time is equals to t, that means this will be t minus 0.5. Why am I saying that? Because the ball was thrown 0.5 seconds later. Are you together? And then obviously the initial velocity is just 40 meters per second. I don't know final velocity. What else? Okay, gravity is just negative 9.8 meters per second. So same thing here, the initial velocity of the ball from position P to X, the initial velocity was positive 15 meters. I don't know final velocity as well. Gravity is 9.8 meters per second squared. Okay, for me to solve here, guys, I need to solve these things simultaneously. Hey, where will I find space to write, Mar? Okay, I was just writing down the data, no, guys. Now let's calculate here. I'm simply going to use the third equation. Why? I don't know the final velocities of the ball and the disk, so I'll refrain from using anything that has a final velocity. So I have delta y being equals to vi delta t plus 1 over 2g delta t squared. Are you together? So delta y, for this one, I'm still focusing on the ball. Delta y is x, and then initial velocity, that's 40, and then the time it took, that's t minus 0.5 plus 1 over 2 times negative 9.8, and then t minus 0.5 all squared. Are you together? And then this will give us 40t. I'm removing the brackets now. 40t minus 20, then minus 4.9. Okay, let me do this. Let me expand. You'll obviously open two brackets, guys. Remember that there's a negative sign over there. There's a negative sign here. T minus 0.5. You'll simply have t squared, and then you'll simply have O minus t plus 0.25. Let me check. 0.5. Yeah, that's 0.25. This will give us 40t minus 20 minus 4.9 t squared plus 4.9t minus 4.9 times 0.25. That's negative 1.225. So x is equals to this thing, guys. This is, do I have like terms? Oh yeah, I do have like terms before I say equation 1. So I simply have 44.9 delta t minus 21.225 minus 4.9 delta t squared. So this is just equation 1. I was still focusing on the ball, ne? Now let's go and focus on the disk. Let me write this one in red. I'm still refraining from using any equation that has a final velocity because I don't know the final velocity. So our delta y right now is just x minus 30, ne? X minus 30, the initial velocity, that's 15, the time, that's t, so 1 over 2 negative 9.8 times t squared. So x is equals to 15t minus 4.9 t squared plus 30. This is just equation 2. So you can see that x is equals to a certain statement and x is equals to another statement. In maths, guys, ne? If a is equals to b and b is equals to c, you can therefore conclude that a is equals to c. Why? Because both a and c are equal to b. So same thing applies here. You'll simply say equation 1 is equals to equation 2. Why am I saying that? Because both equations are equals to x. Ngizoyibhala phi ke lento le? Nkosi yami. Let me try to pin it here. Let me write in blue. Equation 1 is equal to equation 2. Ne? What is equation 1? I have 44.9t minus 21.225, I'm assuming, yes, minus 4.9 t squared. This will be equals to 15t minus 4.9 plus 4.9 t squared, ne? Plus 30. Okay, these two will subtract one another. I don't even want to continue with them, ne? These two will just subtract one another because they have the same sign and they're in opposite sides. If I take this to the other side, it's about plus, and then they'll subtract. So those will subtract one another, and then let me group like terms. I will have 44.9t minus 15t is equals to 30 plus 21.225. So 44.9 minus 15, I'll simply have 29.9t being equals to 51.225. Then t will be 51.225 divided by 29.9. How much that? So t will be equal to 2.57 seconds. So the balls will, the disc and the ball rather will be in contact with one another after 2.5 seconds. What's in? Calculate the time from which, yeah. So this is the time, ne, guys. Remember that, guys, we've taken information for ball X and for ball and for disc C. Are you together? This is the information of the ball, and then the red part is the information for the disc. And then both equations are equal to the same thing because they are at the same height above the ground. Are you together? Yeah, and then I've made equation 1 to be equal to equation 2. Then I've solved for t. That's how, guys, we're supposed to deal with that question. Okay, and then now on the same set of axes, sketch the graph of velocity versus time for disk C and ball B from the moment disk C was thrown until ball B hits disk C. Let me try to draw it here, because the ball was thrown at a speed of 15 meters per second. It went on to reach maximum height. Then it hammered until it was hit. Let's say it got hit here. The time was 2.57. Okay, the time it reached maximum height, did you calculate it? Yeah, 1.53. That's 1.53 seconds. Okay, and then for the ball was projected 0.5 seconds later, at a speed of 40 meters per second. So 40 is somewhere there. So the ball will be like this. It will stop there. So its initial velocity was 40. Yeah, we'll obviously write the heading. You'll write in full, you'll write velocity time graph, and then on the y-axis, that's your velocity in meters per second, and then on the x-axis you have time in seconds. That's how, guys, you're supposed to draw a graph, but since you guys will have a ruler in the exam room, make sure that these two lines are parallel to one another. Just make sure of that. Yeah, so that's how, guys, you're supposed to take that 20 marks. I hope that, guys, you understood. If there are things I'm not sure about, please do ask on the comment section. I'll definitely come back and assist you. Thank you very much.